The universe will end. Not today, not in your lifetime, not even in a billion lifetimes, but it will end. 3 possible futures lie ahead. 3 ways everything that exists will cease to exist. This is what happens when the universe dies. Scenario 1. Heat death. 5 billion years from now, you're standing on Earth. If Earth still exists, the sun has changed. It's not the sun you knew. It's swollen into a massive red giant, filling half the sky. It's dying, and it's taking everything with it. The sun burns through its last fuel. Hydrogen gone, helium fusing desperately. The outer layers expand outward, engulfing Mercury, then Venus. Earth bakes under light 1,000 times brighter than today. The oceans boil away. The atmosphere burns off. The surface melts. If anything survived this long, it watches the sky turn red as the sun consumes the world. Then, silence. 7 billion years from now, the sun is dead. What remains is a white dwarf, a dense core the size of Earth, glowing dimly with leftover heat. Its faint light barely reaches what's left of this solar system. Charred rocks, frozen debris, silence. But the sun isn't alone. Across the universe, nearby galaxies are being pulled together by gravity. They collide, not violently, gracefully. Stars pass through each other like ghosts because space between them is so vast. Over millions of years, galaxies merge into supergiant galaxies, massive islands of stars in an expanding void. 100 billion years pass. The universe keeps expanding. Galaxies that were once neighbors drift so far apart that their light can no longer reach each other. Each galaxy becomes isolated, alone in the darkness. To anyone inside, it would appear to be the only thing left in existence. The stars keep dying. One by one, over trillions of years, stars burn out and vanish from the sky. Some collapse into white dwarfs, some into neutron stars, the largest into black holes. 100 trillion years from now, you look up at the night sky from whatever world remains. There are no stars, just darkness. The last galaxies are now just vast collections of fading white dwarfs, cold, dim, the final reliable sources of light and energy in a quiet universe. Any civilization that survived this long would cling to these dying embers, harvesting the last scraps of energy they offer. Occasionally, by pure chance, collisions create new stars, brief acts of defiance against an unstoppable end. But even white dwarfs are not eternal. 1 undecillion years later, that's a 1 with 36 zeros, the last white dwarf fades. With its light gone, the universe is cast into total darkness. Black holes, frozen planets, dead stars, all drifting in silence. Even the building blocks of matter begin to decay. Protons, stable for eons, finally break apart. Planets dissolve. Dead stars crumble into nothing. Everything that was once solid matter turns to radiation and drifts away. Only black holes remain, the last organized structures in the universe. 1 Google years pass. That's a 1 with 100 zeros. A number so large that all previous ages of the universe are insignificant in comparison. In this distant future, black holes orbit each other in silence, merging, growing larger, the last dance of gravity in an empty cosmos. But even black holes are not immortal. Through a process called Hawking radiation, they slowly evaporate, leaking energy, shrinking. After unimaginable time, the last black hole disappears. Its final light flickers out. The universe is now completely uniform. Energy spread so thin that nothing can happen anymore. No stars, no matter, no structure, no change. Just endless, empty equilibrium. The universe didn't explode. It didn't collapse. It just faded into stillness. But that assumes the expansion stays gentle. Scenario 2. The Big Rip. This future starts the same way. The sun dies. Galaxies collide. Stars fade. But now something different happens. The universe's expansion doesn't slow down. It accelerates, faster and faster. Dark energy, the mysterious force driving expansion, grows stronger. Galaxies that were drifting apart now rip away from each other violently. Groups of galaxies break up, not over billions of years, over millions. 1 billion years from now, the expansion becomes so extreme that it starts tearing apart individual star systems. You're on Earth, or what's left of it. Stars that once filled the night sky are being pushed away so fast that their light can no longer reach you. The sky goes dark, not because the stars died, because they've been forced so far away that you'll never see them again. Galaxies dissolve into formless clouds. Stars scatter, alone in the void. A few million years later, the expansion becomes so violent that even solar systems can't hold together. Planets are ripped from their orbits. Earth is torn away from the sun. The sun shrinks in the sky, smaller, dimmer, gone. Without the sun's heat, Earth's atmosphere partially collapses. The surface freezes solid. Any life that survived this long dies in the cold and dark. But the worst is yet to come. Months later, the expansion reaches into solid objects. Stars are torn apart from the inside. Planets shatter. Hours later, it reaches atomic scales. Molecules break. Atoms are ripped apart. Electrons are stripped from nuclei. And then, in the final moments, the expansion becomes so extreme that even the fabric of space-time itself is destroyed. The universe doesn't fade. It tears. Everything that existed, matter, energy, space, time, is ripped into oblivion. Scenario 3. The Big Crunch. In this future, the universe's expansion slows, then stops, and then it reverses. Gravity wins. The universe begins to collapse. At first, it's subtle. Galaxies that were drifting apart slow their retreat, then pause, then start moving toward each other. Collisions begin, massive galaxies smashing together. But even these are gentle. Stars rarely touch because the distances between them are so vast. Slowly, gravity pulls the universe back together. As space contracts, light, heat, and radiation become more concentrated. What was once empty void now swarms with energy. The cosmic microwave background radiation, the faint afterglow of the Big Bang, begins to heat up. 1 billion years into the collapse, the universe is noticeably warmer. 10 billion years later, it's hot. Stars that once burned alone now bake in the heat of a universe that's shrinking around them. If any living beings survive to this point, looking up at the sky means witnessing the end of everything. Galaxies converge. Light from every direction intensifies. The background radiation grows hotter than the surface of stars. Stars can no longer cool. They overheat and explode. As the universe contracts further, even atoms can't survive the heat. Matter breaks down, nuclei shatter, quarks dissolve, everything compresses, tighter, hotter, denser. And then, the universe collapses back into a singularity. Everything that ever existed, every star, every planet, every atom, crushed into a point of infinite density. But could this end bring a new beginning? Some theories suggest the collapse could trigger another Big Bang, a cosmic cycle, death and rebirth. The universe ending not in silence, but in a new explosion of creation. We don't know. 3 endings. Heat death. The universe fades into cold, empty equilibrium. Big rip. The universe tears itself apart. Big crunch. The universe collapses back into a singularity. We don't know which future is real. We don't know when it will happen. But we know this. The universe will end. Not tomorrow. Not in a million years. But eventually. Everything that exists, the stars, the galaxies, the planets, you, will one day cease to exist. The universe has a lifespan, and like everything with a lifespan, it will die. Right now, the universe is still young, still expanding, still creating stars, but its fate is already written. We're just waiting to see how the story ends. This is what happens when the universe dies. Not with a bang, not with a whimper, just with time. Until the next journey.